Okay, the following is a video over 3.8 notes, and this is implicit differentiation. And what I want to clarify in this section is that we are taking derivatives. So this is derivatives of equations. Okay? This is not functions, okay? This is an equation, all right here. This is an equation, okay? A function is something where you've got like f of x equals and all that kind of stuff. So I went over this problem in the previous video over how to take the derivative of this equation. And this is the derivative. This is the equation of a circle of radius 1. And you can see that I have the equation of that circle here. This is not a function. And what we want to do is we want to find the slope of the tangent line at x equals the square root of 2 over 2. Okay, tangent lines. So what I want to do is I want to, first of all, take my derivative with respect to x. So the first thing I'm going to do is zoom in on this. And let's take our derivative with respect to x. What I'm going to do is I'm going to come here and I'm going to take the derivative with respect to x. And as a result, I get this. I get d dx of x squared plus d dx of y squared. And then I'm going to take the derivative with respect to x of 1, okay? So what I mentioned in the previous video was that if we're taking the derivative with respect to x, and we're taking that of a term that contains an x, we're just going to take the normal derivative, okay? So I'm just going to get 2x here, okay? Now, the next thing I want to show is that if we take the derivative of with respect to x and we're taking the derivative of that and these don't match, okay, then I have to use the chain rule, okay? And so I'm going to take my normal derivative, so I'm going to get plus 2y, but then I'm going to multiply by the derivative of y, which is dy dx, okay? And then if I take the derivative with respect to x of a constant, remember that's just going to give us 0, okay? So what I want to do is I want to solve for dy dx, okay? So I'm going to solve for it like I would any other equation. I'm going to subtract 2x from both sides. And when I do that, I get 2y times dy dx is equal to negative 2x, all right? And so if I divide both sides by 2y, then I end up getting that dy dx, okay, after I divide my 2's out, is going to equal negative x over y. Now, what I want you guys to notice is that this is my derivative, okay? But it's in terms of the variable x and the variable y. Okay, so what I want to do, remember, and this is going to do the same thing as any other derivative. It is going to generate the slope of the tangent line at any point. But I have to have an x value and I have to have a y value. Okay, so if we go back and we think about what this wants us to do, it says find the slope of the tangent lines at x equals the square root of 2 over 2. Now, what we know about, and I don't want to necessarily go through this, but when x is the square root of 2 over 2, that's a point on the graph right about here at 45 degrees. Okay, so when x is the square root of 2 over 2, then we also know that y is the square root of 2 over 2. Okay, and this is just from trigonometry in the unit circle. Okay, now since I have an x value here, all right, I have two different y values. Okay, I have this positive y value when x is the square root of 2 over 2. But I also get this value over here, and this is the square root of 2 over 2, and then this is negative square root of 2 over 2, okay? And so if I go back, let me make sure I'm answering this question right. Okay, given the equation of the circle, find the slope of the tangent lines at at these values. So what I want to do is I'm going to do it for this point first, all right? And so if I wanted to find dy dx, and here's the notation that we would use, okay, if I wanted to evaluate dy dx at that point, then I would say dy dx is equal to, or I'm sorry, I shouldn't do that, not equal to. Let me erase this real quick. We say dy dx evaluated at x equals the square root of 2 over 2 and y equals the square root of 2 over 2. Then we simply just plug those values into our derivative, which is negative x over y. Okay, and so plug it into that, and we're going to go ahead and end up getting negative square root of 2 over 2 divided by the square root of 2 over 2. And this ends up giving us negative 1. Okay, now we got to think about what this number is. This is the slope of the tangent line, okay, at this point, x equals square root of 2 over 2, and at this y value, positive square root of 2 over 2. So if we go back and we look at our graph, okay, and if we were to come in here and draw a tangent line at this point, all right, it's going to have a slope of negative 1. So my slope here is negative 1. All right, so now let's go back and let's take a look at what would happen at this point down here, okay, at the square root of 2 over 2 and then negative. That should be a 2. Doesn't look very good. And so when I do that, I'm going to come in here and do it on my derivative, and I'm going to say that dy dx evaluated at x equals the square root of 2 over 2, and then y equals negative square root of 2 over 2. Then we end up getting this. We end up getting negative square root of 2 over 2 divided by negative square root of 2 over 2, and that gives us positive 1. Okay, now this is the slope of the tangent line at this point, and that's a slope of 1. Okay, and so you know, that's what we're doing here, and I wanted to show you that this is the most basic problem that we have, okay, when it comes to using implicit differentiation. And I hope that this makes sense to you as to what we're doing. But I do want to note that it is very important that we understand what's going on here and how to take this derivative. Okay, this is something that is pretty important when it comes to doing this for AP and stuff like that. So I'm going to go ahead and stop the video there, and I will continue on with this video in the next couple videos. Thanks.